Hello children, welcome to channel Sube. Children, today I am going to discuss question number 9 from the MCQ part of 2022-23 Physics New Syllabus paper. The figure shows the path AB, the path is this one, of a ball projected from point A. Neglect air resistance. Consider the following statements. Capital A, the velocity of the ball at the maximum height of the path is 0. Capital B, the velocity of the ball at point B is equal to the velocity at point A. C, the kinetic energy of the ball at point B is equal to the kinetic energy at point A. Of the above statements, only A is true, only C is true, only B and C are true, only A and C are true, all A, B and C are true. So children, let us consider this statement A. The velocity of the ball at the maximum height of the path is 0. Maximum height means this place, maximum height. So the ball at maximum path is like this. The velocity of the ball at the maximum height of the path is 0. At the maximum height, the ball is moving like this. So when the ball is at this place, you know the velocity, the vertical velocity component is 0. This one is 0. But there is still a horizontal component. So it is equal to, if this angle is theta and the initial velocity is u, then the component to this side, the horizontal component is u cos theta, we know that. So it doesn't change, always u cos theta value is there along this path, because there is no acceleration or deceleration to this side. Horizontally there is no any force. Neglect air resistance. Therefore it moves horizontally at a constant velocity, at a steady constant velocity. So here the velocity u cos theta part is there. That is the component. So this one is 0. This one is 0. Therefore we don't have to write it. We can delete it. So the final velocity is this one at maximum height. So it is not 0. So it has a value. They have not mentioned here in this statement the vertical component. They have said, what they have said is the velocity. So the velocity is this one. If they have mentioned the component, vertical component is 0, then that is correct. The vertical component is 0, but they say not the vertical component, totally the velocity. Velocity doesn't go to 0 because it has the horizontal component. So the final velocity is this one. This is what we can call the velocity. So it has a non-zero value. So therefore this one is wrong. So children, they have given this statement because normally we say at this point velocity is 0. So we mean, what we mean is the vertical component is 0. But always we don't use that word. Sometimes we say the velocity at this place is, because we apply this equation to v equals u plus at equation to this vertical direction. So therefore normally we don't say, we substitute 0 here at this point. So to make a mistake according to that, because we are used to say that, therefore they think that we might make a mistake, because we say always velocity is 0. So that they have given us to make a mistake like that. Now let us focus our mind to the statement B. The velocity of the ball at point B here is equal to the velocity at point A here. Let us check it. The velocity is this one at point A. So this is the velocity. So say it is u. The angle is theta. Then here, what is the velocity? To this direction, the velocity is to this direction, the magnitude is u, that is correct. theta also correct, but the direction is not same. Direction is not same. This one upside, this one downside. So therefore the direction is not equal. Therefore, even though the magnitudes are equal, but the direction is not equal. Therefore, we can't say totally the velocity is equal. We can't say velocity is equal. If they say speed, if they said the speed of the ball at point B is equal to the speed at point A, then it would have to be correct. But now it is not correct, because they have said velocity. If it is velocity, the magnitude should be equal, the directions also should be equal. Both should be equal to say velocity is equal, but here the direction is not equal. Therefore, this one is totally wrong. So now this one, statement C, the kinetic energy of the ball at point B is equal to the kinetic energy at point A. So kinetic energy, so it is a scalar, not a vector. Therefore, we don't have to worry about the direction. Kinetic energy is half mv squared. So m is constant, it is equal at A and at B both, and velocity, the velocity without the direction, we have to get the velocity without the direction, that is the speed. So to find out the kinetic energy, we have to consider the speed, not the velocity. Therefore, we don't have to worry about the direction. So the speed is equal. So the magnitude of the velocity is speed. So only we have to take the magnitude. So magnitude is equal, magnitudes are equal here and here. Therefore, the kinetic energy is equal, that is correct, because kinetic energy is a scalar, not a vector. Therefore, we don't have to worry about the direction. Only the direction is different here, but the magnitudes are equal. So therefore, kinetic energies are also equal. So that is correct. Therefore, the kinetic energy of the ball at point B is equal to the kinetic energy at point A, that is correct, because it is scalar. So after all, only C is correct, only C is true. So this one is the answer. The second one, let us check the answer. Question number 9. Question number 9, 2. The second one is the answer. So we have selected this one, so it is correct. So children, I remembered I didn't explain why this velocity is 0. You might know that, but for those who has problems, I didn't explain it when I was discussing the first statement. So now I am going to discuss it, why it goes to 0. We know that velocity component, the vertical component of the velocity is 0 here at the maximum point of the path, because there is a acceleration, gravitational acceleration they have given it as a clue. Even it may be they have given it maybe as a clue, because we know that there is a acceleration that equals to g here. We don't have to be given it. So they have given it as a clue, I think, because the vertical component of this velocity little by little decreases like this when the ball goes up. So very small values here. So finally here nothing, because there is a force, gravitational force to the opposite direction of the motion. So therefore there is a deceleration here. When the ball is going up, there is a deceleration. According to the deceleration, the velocity decreases little by little. So at this point, the vertical component of the velocity is 0. Therefore we consider at this maximum point the vertical component is 0. It is like that. It is at the beginning like this, a big value, So next time it is a little bit shorter, next time it's more shorter, like this, the arrow. So the magnitude also decreasing. So finally here nothing to this direction, only the horizontal component is there, it is not decreasing, it is same. So I have to measure it like this. So it is same like that. I have to draw it. If I draw it correctly, so I have to copy this and place if I draw it correctly, because it is not getting shorter. So like this, it is always the same, the horizontal component is same. So at the top only the horizontal component is there, the green color vertical component is 0. So there's nothing vertically, so that is why we take this vertical component is 0. You may know that, but some students might expect me to explain it. So therefore I explained it. Now I think you are happy. And also some students might expect me to explain why this one is constant, this red one is constant. I explained it, I said just it's correct. So most of the students know that, but some students who has missed this lesson might have problems, because to this direction there's no gravitational law, any kind of force or acceleration. They have shown only vertically there is a acceleration. To this direction there's no acceleration, because they have said neglect air resistance also. If there's a wind, this one is not constant. If there is a wind, it little by little increases due to the force given by the wind. So the acceleration, to happen acceleration, there must be a force. F equals ma, you know. So there must be a force to have an acceleration. So there's no force horizontally like this, there's no force, you know, the gravity is to this direction. So at perpendicular direction it has no effect. So therefore perpendicular this direction is the horizontal direction. So to this horizontal direction there's no force. So therefore, since there's no force, there's no acceleration or no deceleration, therefore the velocity is constant. This one is u cos theta, always u cos theta. So we can copy paste this at every place like this. Like this we can say it is cos theta. Theta is constant because that is the initial one, even though the theta is changing when it is rising up, but not those thetas. We get only this initial value. Initial value is only one, so it doesn't change. Initial value, this one is initial theta, So therefore the horizontal component of the velocity is constant along this path. Even here it is constant, everywhere it is constant. Like this, everywhere it is constant. So in this lesson you learn it, but some student might have problems about this lesson. Therefore that is why I explained everything. So now I explained everything, so I think you are happy. So due to this gravity is always here along this path, there is a force as I explained downwards in green color. So there is a force everywhere, there is a force. Therefore when the ball is rising up, the velocity, the vertical velocity is decreasing because due to deceleration. At this path, at this side, when the ball is coming down, it accelerates due to this gravitational force. It accelerates at this side, this half. So beginning from 0, little by little, it is the velocity is increasing. Finally here there is a velocity, vertical one, vertical component equals to this initial vertical component. Children, here is our target question. Now what you have to do, read the question carefully and pause the video and try to find out the answer on your own. Honestly do it. Now pause the video. So children, I think you have selected by now selected the answer. The statement A, the vertical component of the velocity of the ball at the maximum height of the path is 0. That is correct, because at the maximum height the vertical component only, not the velocity. Vertical component is 0. That is correct. The speed of the ball at point B equals to the speed at A. That is also correct, because without regarding the direction, the speed is same. Only the direction is different here. So now we are not considering the direction, only we need the speed. So those are equal. Speeds are equal. Therefore this one is correct. The kinetic energy of the ball at point B is equal to, that is also correct, because kinetic energy is a scalar, so therefore we don't have to consider the direction. So m is same, and half mv squared is kinetic energy. So the magnitude of velocity is equal, only the direction is changed. Here we don't have to consider the direction. Kinetic energy is a scalar, therefore this one is correct. So all are correct, all A, B and C are true. So the fifth one is the answer for this target question. Children, next time you might get, if you are lucky. So sometimes they do little change and give the same question. Sometimes they don't give same questions, entirely they change the question. So unless you might get something like this, then you are lucky. Children, here is our next target question, the target question number 2. So try it on your own without watching my answer, honestly. So pause the video and read the question carefully and try it. Actually, now I am going to solve this, discuss this. The velocity of the ball at the maximum height of the path is u cos theta. So here the velocity we have to find. You know, this way the component is 0. Therefore we don't have to write it. Only the horizontal component is the final velocity. So the horizontal component of here is u sin theta according to the theta given. The theta given is from the vertical, but normally we are given the theta to horizontal, but here the theta is to vertical. Therefore not the normal u cos theta. Here according to this question you have to take u sin theta, because away from this theta we have to turn it away from this given theta. Given theta you have to consider the given theta, not usual theta. So here u sin theta. So this velocity is therefore equal to u sin theta, because the horizontal velocity is same, it doesn't change, because since then there is no force, so acceleration to this side, only the acceleration is to this side, that is perpendicular. It has no effect on this one. So therefore the u sin theta is the final velocity, since there is no velocity to the vertical side, upwards there is no velocity. We know that here the velocity is, the component is, vertical component is 0. Therefore only the horizontal component is the final total velocity. So it is u sin theta, not u cos theta. So this one is wrong. So now the statement B, the velocity of the ball at point B is equal to the velocity of, already we know that it is wrong because the direction is not same here and here, the direction is different, therefore we can't say it is equal, because to be equal and the magnitude and the direction both should be same, but here the direction is different, so therefore the velocity is not equal. Here they say it is equal at A and B, so it is wrong therefore. So let us go to this statement C. The momentum of the ball at point B is equal to the momentum at point A. So here what they ask is momentum. Momentum is the MV term. Momentum. Let us normally say momentum. So since it has this value V, it has a direction. If it is this one is the velocity, you know. So since there is this velocity in this term, the direction is not same, therefore the velocity is not same. Since the velocity is not same, the momentum also is not same, but here they say it is equal, so this one is therefore wrong. Here the momentum is to this direction, it is the direction of the velocity, so here the momentum is to this direction, same as velocity, so therefore there are two directions, so therefore not equal, the final one is therefore wrong. So all are wrong, all A, B and C are not true, so this one is the answer, the fifth one. So if you are successful in this question, children, you are good at this lesson, you are good at this lesson, projectiles. Children, here is our next target question, the target question number 3. So try this on your own, without watching my answer, honestly. Pause the video now. So I am going to discuss this now. I think you have chosen the correct answer by now. So what they ask is, at the maximum point, the velocity of the ball at the maximum height, So here the velocity we have to find. So there is in this question there is an acceleration horizontally. So let us so therefore we have to calculate, we can't just argue and take the approach the answer. So here the velocity. So the initial first of all we have to find out the time for this part, say t. So let us calculate to this direction, vertically upwards. So the initial velocity, what is it? To upwards, the u is u sin theta. So this way we have to turn it away from the theta, therefore u sin theta. So what is the acceleration upwards? Minus g. They have not given it, but it is not necessary, you should know it, the g is to this way. So we are considering upwards, so it is a deceleration, therefore minus g, that you know. Here the velocity, the final velocity is going to be v. So v is going to be 0. V should be 0 because that is the maximum height. V is 0 at that point, upwards the component, not the total v. What we need? Time. It has no direction, therefore I don't mark arrows, I don't draw arrows. So what we use? V equals u plus at to this direction. Always I mark directions when I use these equations, then no mistakes, there's no chance to get mistakes. So v should be 0, so u sin theta, initial velocity upwards is u sin theta. So it is a deceleration, and also here we have written minus g, acceleration is minus g. The time t we don't know, that's what we are going to find out. So we take that to this the term to left side, so it becomes positive, then u sin theta. What we need is t, we isolate t, u sin theta divided by g. So here we stop for a moment. Now we know t. Now we calculate to this side. So the topics must be there. To this side, what is the initial velocity? U cos theta. This way u cos theta, because you have to turn this towards the angle, therefore u cos theta. Then what is the acceleration to this side? They have given it in the question, g divided by 8 amount. G divided by 8 amount. There is a wind blowing to AB direction. AB direction is to this way. So that is like that. G divided by 8. That is a positive one, because it is an acceleration. So what else we need? T. T we know already. The same t, this one. U already what we have found. U sin theta divided by g, because the both motions are simultaneously happening to upwards and to right side, towards this maximum height. So the both the motions are happening at the same time, therefore they are happening together simultaneously. So the time is same for both topics, vertically or horizontally, the time is same. So we use therefore this already what we have calculated. T is that one. At the same time it moves towards this way at the same time. So the time is equal. So what we need is velocity to this way, final velocity, this one, this one. That is what we are going to find out, the velocity of the ball at the maximum height. So that component, first let us find out that component. So it's a question mark. So let us use the same equation, v equals u plus at. So we are considering this direction. T has no direction, it is a scalar. We don't know this v, therefore just as it is. U is u cos theta, this one. Plus, here plus because it is an acceleration. A is g divided by 8. It is given in the question. The time is this term u sin theta, this one, divided by g. So whatever is there possible to cancel, this one. So final v is u cos theta plus u sin theta divided by 8. So since the ball has only this v, because this one is 0, we have to finally write the velocity to this way is this one, this one only. We don't have to combine using Pythagoras theorem, just only this component is there to the horizontal right side, so therefore that is what we have already calculated. So there's nothing to go to the parallelogram and finally find out the resultant. There's nothing, because since this one is 0, because we are at the maximum height. So at the maximum height we know that the vertical component is 0, therefore only the horizontal component. So that is what we have now found. The horizontal component is finally this one. So u cos theta plus u sin theta divided by 8, that is the answer. U cos theta plus u sin theta divided by 8. So this one is the answer, the first one. So that is the final answer. So children, what happened to you? Are you successful? If you are successful, you can be happy. You are good at this lesson. You are genius. So let us wind up for today. So children, now I am going to wind up. First what we did, this original question, the MCQ 1 2022-23 paper, the question number 9, we discussed it, and then we discussed this target question number 1, and also then we discussed this target question number 2, and also we discussed this target question number 3. So today we discussed altogether 4 questions. I think you are happy, children. So now you know, you have to make me happy too. You know how to do it. You have to subscribe my channel if you still haven't done it, and also please share my link among your friends and press the bell icon, and also give me a like. And also thank you very much for the students who watch my videos, do it again and again, and also thank you very much for those who already have subscribed and who are subscribing today. Then let us see you tomorrow at 6 o'clock in the evening. Goodbye, children.